Alright, we have another easy question, okay, that tells us to solve for x. Now, whenever I see a question like this in logarithms, where there's an equation and an unknown, it simply means it's a logarithmic equation, okay? And in such equations, we need to look for the unknown value in the question. Now, remember that you have to have mastered the laws because we need the laws to be able to solve something like this. So it means that you're supposed to have all the laws rolling in your head when you want to attempt questions in logarithms. Now, the first thing we do, we're already saying that what we have here is a subtraction sign, okay? And I'm also saying that the base is x and the base is the same, okay? Before we apply the laws, we must be sure that the base is the same. So, going straight, we can just say here that since we are having a subtraction sign here, I can just pick a log here, log x, then it will be this divided by this. So we have 8x minus 3 over 4. Okay, this is what we have here, being equal to 2. Okay, now at this point, we can easily do this at this point. Remember that if we recall, whenever we have log x to base a being equal to y, remember that x is a to the power of y. Remember, so we are going to apply this concept here. So it means that x can carry 2. So we can say that 8x minus 3 over 4 is going to be equal to x to the power of 2. Okay, so without wasting time, we cross multiply. When we cross multiply, we are going to have that 4 times x squared gives us 4x squared. Now also 8x minus 3 times 1 is going to give us 8x minus 3. Okay, now we can rearrange what we have here so that we have something like this. We have 4x squared. Now if 8x should move over to this side, we're going to be having minus 8x. Okay, and if negative 3 should cross over, we're going to be having positive 3 being equal to 0. Now what we have here is a quadratic equation. Okay, so how do we solve quadratic equations? The first thing we do, we multiply this side and this side. We multiply these two. Okay, we multiply this term here, the term that has the highest power of x. Okay, that has x squared. Okay, and the constant term, that is the term without the variable. So when we multiply both of them, we are going to be having 12 12x squared. Okay, now from this 12x squared, we are going to produce two factors. Okay, such that when the factors are added, we are going to have minus 8x, and when the factors are multiplied, we are going to have 12x squared. Now the best factor to use here is 6 and 2. Okay, I'm going to use 6 and 2 because if we use minus 6x minus 2x, minus 6 minus 2x, we get minus 8x, and minus 6x multiplied by minus 2x, we're going to have 12x squared. So these two are accepted factors. All right, so it means that we can replace minus 8x with minus 6x and minus 2x. Okay, that gives us uh, then plus 3 equal to 0. So what we have here, we can now group into two terms such that when you check here, if we bring out 2x from here, 2x is common. If we bring out 2x, we have 2x into, we'll be left with 2x here, and we'll be left with 3 here. Okay, then 1 is common. Okay, if we bring out 1, we'll be left with what we have here. Okay, minus 1 is common, so we bring out minus 1, we're going to be having negative 3 here being equal to 0. Okay, now take note, we have to bring out, remember that the term here and the term here should tally, they should be the same, which means in respect of the signs, the sign should also tally. Now when we brought out my negative 1 here, negative from negative we left with positive, and negative from positive we left with what now? Negative. So at this point in time, 2x minus 3 is common. We can bring it out. If we bring out 2x minus 3 from here, okay, in this term, we'll be left with 2x here. And in this term, we'll be left with minus 1 equal to 0. Okay. So at this point, we can equate this to this. If we equate 2x minus 3 to 0, okay, we'll have 2x minus 3. If we equate to 0, we'll have that 2x is equal to 3. We'll also have that x is equal to 3 over 2. In the same way, if we equate 2x minus 1 to be equal to 0, we'll have that 2x minus 1 equals 0, which means 2x is equal to 1. And that also implies if I divide both sides by 2, we have that x is equal to 1 over 2. So it means that finally we have two answers for x. We can say that x is equal to 3 divided by 2. Let's call that the first x. And we can also see that x is equal to 1 over 2. Okay. So this is the answer to the question. Okay. All right. This is another question here that says simplify this expression. Okay. Now, when you hear the word simplify, what it simply tells you is that break anything that you have, break it down into its simplest form. Okay, now while I observe this question, I'm seeing that what we have here is the fourth root of the total root is fourth root. Then within the fourth root, we have a third root here. Okay, now I can also see that there is a relationship here. Okay, the base can be made to be common. Okay, 7 to 9 is same thing as 3 to the power of 6. 7 to 9 is the same as 3 to the power of 6. 9 is same as 3 to the power of 2. And 27 is 3 to the power of 3. So we can say this from here, that log 3 fourth root. So 3 fourth root is 3 to the power of 6. Okay. Third root, 3 to the power of 2. 2 times minus 1 gives us minus 2. Then what we have here is 3 to the power of 3. Then if I multiply 3 to the power of 3 times 4 over 3, the 3 cancels out. So we have minus 4 left. So look what I mean here is if I have 3 raised to the power 3 multiplied by minus 4 over 3, this cancels this. We have minus 4 left. Now at this point, we can apply indices at this point here, okay, for these two guys. And when we do that, we have that log to base 3, fourth root, 3 to the power of 6 dot third root. Okay, now applying indices for these two, we'll be left with 3, negative 2, negative 4 gives us negative 6. All right. So at this point in time, we could say that we're left with log to base 3. Okay, we still have the fourth root, then 3 to the power of 6 multiplied by, now this is same thing as saying 3 to the power of negative 6 times half. Okay, times 1 over 3. Okay, why? Because this is a third root, so we can say this is times 1 over 3. So these two guys can go out here. So we have that log base 3. Okay, so at this point in time, we're now having 3 to the power of 6 dot 3 to the power of negative 2, then to the power of 1 over 4. You can say this now at this point. Now remember that if we apply indices here, it becomes 6 minus 2, picking a common base 3. So we have log to base 3, 3 to the power of 4, then multiplied by 1 over 4. Okay, 4 can cancel at 4. So we are left with log of 3 to base 3. And remember that from the laws of logarithms, log of a number to the same base gives us 1. Okay. All right, the question here says that we should simplify this term. Okay. So remember, to simplify means to reduce it to a very simple term. Okay. or break it down to its simplest form. All right. Now, if we want to treat this, remember that 27 can be written as 3 to the power of 3. Okay. 27 is 3 to the power of 3. Remember, this is the square root. Now, remember also that 8 is 2 to the power of 3. Then also 10,000, 1,000 is 10 to the power of 3. Okay. 10 to the power of 3 divided by. Also remember that 1.2 is same thing as in fraction. We could write 1.2 as 12 divided by 10. Okay. Now, remember also that this is a square root. All right. So in indices, I could write everything I have here as log of 3 to the power of 3 divided by 2. Okay, because it's a square root. All right. So this guy can be written like that. Then also, this same thing as saying log 2 to the power of 3. Yes. And this guy, we can still write this guy like this, 10 to the power of 3 over 2 divided by. Now, we could spread this to be log 12 minus log 10. Okay. Now, from the law of logarithms, we know that these guys can move to the back. Okay. These guys can move backwards. All right. So I can say from here that 3 over 2 log 3 plus 3 log 2 minus 3 over 2 log 10 divided by. Now we know that 12 can be written as 4 times 3. Okay. Now what I'm trying to do here is I'm trying to see how I can uh, bring out common terms in the numerator and the denominator so that I can cancel out. Okay. Now I'm already seeing that I'm seeing log. We can actually factorize 3. 3 is actually common. Okay. So when we bring out 3, okay, we're going to be left with 1 over 2 here, log 3, okay. Then we have removed 3 from here, so it becomes, we'll be left with log 2. Then down here, we'll be left with 1 over 2 log 10, okay. So we can say divided by. Now, since we are having multiplication here, we can actually apply our rule of log again. So this is simply as writing log 4 plus log 3 minus log 10, okay. Now, at this point here, you can see that we are very, very close to producing a common term here and here, okay, so that they can strike out. Now, I can still go further to say this. We have 3 into 1 over 2 log 3 plus log 2 minus 1 over 2 log 10, okay, divided by, now this same thing as saying log 2 to the power of 2 plus log 3 minus log 10, okay. Now, if this guy comes backwards here, okay, if it comes backwards, we're going to be having this. We're going to be having 3 into 1 over 2 log 3 plus log 2 minus 1 over 2 log 10 divided by, this is something I'm saying 2 log 2 plus log 3 minus log 10. Now, since we want to make the numerator look like denominator, we can decide to factorize, bring out 2 from denominator. Okay. Now, if we bring out 2, if we bring out 2 from the denominator, we're going to have something like this. Okay. We're going to have something like this. We bring out 2, we're going to be having 2 log 2 over 2 plus log 3 over 2 minus log 10 over 2. We're going to be having something like this. Okay. So we're very close to our answer, very close to our answer here. So you can see clearly that what we have left is 3 into 1 over 2 log 3 plus log 2, okay, negative 1 over 2 log 10 divided by, now since we brought out 2 here, now we can just rearrange it, okay, we can rearrange it, so we allow this guy come first, okay, so this is something that's saying 1 over 2 log 3, then 2 can cancel out 2 here, okay, we have plus log 2, okay, then minus 1 over 2 log 10. Now this is our main goal. You can see that we have been able to make the term at the numerator at the term at the denominator. You have been able to make them the same, so we can actually strike them out. Okay, so this when these two go out, our answer is 3 over 2. Answer is 3 over log question. We have been asked to solve for x. So this means that what we have is a logarithmic equation, all right? But I can clearly observe that the bases are not the same, okay? And remember that before we can apply the rule of logarithms, we must be sure that the bases are the same. If the bases are not the same, we can make the bases the same, okay? Now, how do we solve this question? It's a very simple question, very easy. We can actually decide to do something like this here. This seems to be saying log x to base 2 plus log x. Now, 4 is the same thing as 2 to the power of 2 on the base. Now, plus log x 16 is 2 to the power of 4. This is equal to 21 over 4. Now, remember I showed you a log rule that tells us that whenever we have log of x, okay, to base a raised to power n, we could write this as 1 over n log x base a. Remember we said this, I taught you this already. Okay, you can check out my previous videos, okay? I explained this law for you. So if we go by what we just said here, I can say this same thing as saying log x base 2 plus 1 over 2 log x base 2 plus 1 over 4 log x base 2. This is equal to 21 over 4. Now, I can see clearly that log x base 2 is common, so I can say that if I bring out log x base 2 from here, I'll be left with 1. If I bring out log x base 2 from here, I'll be left with half. If I also bring out log x base 2 from here, I'll be left with 1 over 4. Okay, so this is what we have. Log x base 2 is equal to 21 over 4. At this point, you can add everything we have here. We'll add them. We are saying 3. This thing are saying 3 over 4, 3 over 2. LCM is 4. Okay, LCM is 4. So we have 4 plus 2 plus 1. Okay, log x base 2 is equal to 21 over 4. Okay, so at this point in time, we can say this thing are saying 7 over 4 log x base 2 is equal to 21 over 4. Alright, so we can divide both sides or multiply both sides by 4 over 7. Okay, if we do that, this goes out, and what we have here is log x base 2 is equal to 3. Now, at this point, I remember that the 2 can carry 3, so that x becomes equal to 2 to the power of 3, and that is equal to 8. Okay, so this is okay. This question simply tells us that we should find the relationship between a and b. What it simply tells us is that using the laws of logarithm, we are going to look for an equation that will connect a and b. Okay, now it's a very simple question also. The first thing we're going to do here is let's see how we can um, make the bases the same. Okay, now We can also decide to move this to the other side. So we can say this same thing as log a to base 4 minus log b to base 8 is equal to 1. At this point in time, we can also say this same thing as 1 over 2 log a base 2. We are supposed to say this same thing as 2 raised to power 2. So applying the rule of log, the 2 can come back as this. This is also the same thing as saying 1 over 3 log b base 2. Remember that we can say this as log a base 4 a 2 raised to power 2. Remember from the rule I taught you, 1 over 2 log a base 2. Okay, now we can do the same thing for log b base 8. As for log b base 8, we can say this same thing as saying log b 2 raised to power 3 in the base, and this gives us 1 over 3 log b base 2. This is one of the rules of log. Okay, so that's what I applied here. This same thing as what now? Equal to 1. At this point in time, this is same thing as writing log root of a minus log cube root of b to base 2, remember, is equal to 1. So from our rule, we know that this is same thing as log to base 2. Since we have a subtraction sign here, it's going to be square root of a divided by cube root of b being equal to 1. Okay. Now, from what we know, we could say 2 to the power of 1. 2 can carry 1, so that we have that square root of a over cube root of b is equal to 2 to the power of 1. So this means that square root of a is same thing as 2 cube root of b. Okay. Now we can decide to square both sides so that we can remove the square root. Okay. So this gives us a is equal to 2 squared gives us 4. Then this gives us b to the power of 2 over 3. Now we can also decide to remove the cube root by cubing both sides. Okay. So we could cube both sides. And what we're going to have, we're going to be having a cube is equal to 4 raised to power 3 is 64. So we have 64. Then this 3 can cancel out this 3 here. So we have b squared. Now you can see that we have been able to create a relationship between a and b using the rules of log. Now what we did here, now what's the reason why we squared both sides? Because I wanted to remove the square root. Okay, I wanted to have a situation where I have just a. So I actually squared both sides so that I can remove a. Then when I got to this point, why did I cube both sides? I wanted to actually remove this cube root. Okay, so I can actually remove the cube root. So I cubed both sides. So this is the final answer